It's not.
So if I were to like the constant whatever, could it like I don't know how to write it down, but would it be 20 to 29 as a maximum, or is it
It will
just
be 20 comma this, whatever this value is. Let's put a value here, right? So let's say 15. So this is 10 and this is 5. The local maximum will be 20 comma 15 if we accept that equal symbol is okay.
I mean, can you just
For the local max, this will be 10 comma 10. 10 this 10 will be where the maximum occurs, and this 10 will be how much the maximum is.
But what about at the point of
This?
at the x value of 21?
When x is 21. Yes, you have a good point. I would consider all these acceptable as local max and, if you want, local min. But the book says no. The book says this is not a local max and this is not a local min, because on one side is the same number at either side. So on this side is the same number with this. On this side is the same number with that height. And the book says no. So there is no local max and there is no local min here. So this is nothing. They consider it nothing.
So is it always like that when it's constant?
According to this book, yes.
Okay.
Very good. So let's look at symmetry now. Last thing before we look at a problem that will ask us a lot of questions. A function can be symmetric. It's nice if it is, but it's not always the case. But if a function is symmetric, it can be odd or even. This has nothing to do with even numbers and odd numbers. It only says that the function is symmetric or is not symmetric. Okay? If it is odd, it will have a certain kind of symmetry. If it's even, it will have a certain other kind of symmetry. Or the function is not symmetric at all. It's not odd, it's not even. Is there a function that is odd and even at the same time? Yes, but nobody cares about it because it's the function f of x equals 0. Who would care about f of x equals 0? No one. So once I know that the function is odd, it cannot be even. If I know that it's even, it cannot be odd. And let's analyze a graph from each, and we'll come up with the conclusion together. Okay, this is a function that we will see in chapter 3. Any questions? Any questions? Did I do something? Did I say something? Okay, so here's a function. We will see this function again and again in functions that are very close to this shape. Okay, here's what I'm going to do next. And so this is function f of x. So please stay with me. I'm going to pick a point in the third quadrant. I'm going to draw a line segment through this point and the origin. And I'm going to extend it till it hits the graph on the other side of the origin in quadrant 1. So I connect these two. I extend this line segment, and it hits the graph of f of x again in the first quadrant. Now I need you to help me here. If I say this is x, please help me tell me what this is. Yes, but I'm still, thank you very much. You're absolutely correct. I just need to explain this. So now forget about this for a moment. And please tell me, what do you think, according to my graph, what do you think this is? Thank you. Awesome. And now, without looking at the top, please tell me what this is. Awesome. Stay with me. And now let's look at the whole picture. And I'm going to ask you, if this is -5, how much is this? Right, makes sense, right? If I say that this is 10, how much is this? Right. This is the property of any odd function which will be symmetric with respect to, thank you, symmetric, WRT, you know I'm lazy, with respect to the origin. WRT, with respect to the origin. So then, what is the relationship between f of negative x and f of x? That's not possible. Because we said, if this is -5, then we said that one is correct. So they cannot be equal. One is here and the other one is over there. Perfect. Okay. Very sophisticated, your colleague said. The right thing. This is true. It's the opposite. And yes, in absolute value, they will be equal. So for now, we will say that f of negative x is the opposite of f of x, correct? If f of x is 10, then this will be -10. Very good. Well done. Perfect. So now let's look at another type. So this is one type of symmetry, and there is one more. So let's look at this graph. Here's my graph. We know what this function is, but forget about it right now. It's not important. And I'm going to pick a point like I just did. And please give me, so this is x. I'm going to draw a horizontal line through that point. And I would like you to tell me what this is. By construction, of course. Perfect. Now I would like you to tell me what this point is here. Do not look on this, say, on the left-hand side. Just look on the right-hand side and tell me what is this height. Very good. Don't look on this side, and now please tell me what is this height. Very good. So this point is of negative f of negative x. And this is, the graph is symmetric with respect to WRT with respect to. Okay, here it is. Y-axis. Very good. And now please give me the relationship between the same two things, f of negative x and f of x. Absolutely. For an even function, they must be the same. If the function is not even, they will not be the same. Any questions? Okay, perfect. So now let me give you a couple of examples, and then we'll look at a function and analyze it from all points of view, max, min, increasing, decreasing, x and y intercepts, everything. Okay, so I'm picking a problem, and you can too. On page 250. Any problem you want to work on from 37 through 48. 37 through 48 on page 250. If not, I will pick.
33.
33.
Oh, wait. Sorry.
No problem.
I almost confused with it. 43.
43 it is. Perfect. In 43, we are given f of x equals x squared minus x to the fourth plus 1. The question is asking us to determine algebraically, not graph it, just determine algebraically whether it is symmetric or not. So let's look at these two relationships, relationship 1 and relationship 2. What do you think we need to, bless you, what do you think we need to start with? What do we need to calculate or determine?
If it's even or odd.
Yes, what do we need to start by determining or calculating in order to get to the answer, whether it's odd, even, or none of the above?
The degree.
If you look at these two relationships, you will say, oh, I know you have to determine In order to determine whether it's symmetric, I have to calculate something. Look at these two relationships and say, you cannot determine anything unless you calculate. I have to get to that point. What is common to these two relationships that you see in both? Say it again.
Is it a range of domain?
No, I don't have any range or domain here. I'm looking at two relationships, and there is something that they have that is identical in both. F of negative x. This is what I have to calculate. If I don't calculate this, how do I know if it's that? So it's the same in both relationships. We have to determine f of negative x. Let's determine f of negative x. That's the starting point. That's the first thing we need to do. Good. So please dictate. How do I determine f of negative x? We just evaluated functions a few minutes ago. That's why, for this. So what will you tell me to write? Say it again. Say it again. Careful.
You square negative.
So let's look at this function one more time. This is what it tells us. This is what it tells us. This is the pattern. So now I want to determine f of negative x. Very good. I cannot. I have to take it to the fourth power. Do not change anything. We have to raise it to the fourth power before we multiply by negative 1. So I have to copy negative. Then. Very good. That's it. So that's why it's so important to understand what the function is telling us, because when we want to evaluate it for anything, we should be able to fill it in. Is this clear? Everyone? Perfect. So now please tell me negative x squared. What does that equal? Very good. Squared. Good. How much is negative x to the fourth power? X to the fourth with minus in front. I just have to write it. And plus 1. I have at this point 3 questions to ask myself, and only one of them has the yes answer. The other 2 have to have no. Does this equal the function itself? Does it equal the function itself? If we say yes, the function will be even. Does this equal what is the other option? Very good. Does it equal the opposite of f of x? If the answer is yes, the function will be odd. And the last possibility is no symmetry whatsoever. None of the above. So we determined f of negative x. So now I compare it to the original function. Are they the same?
Yes.
So there is a yes. And these 2 are gone. The function is even, and if I were to graph it, I would graph it symmetric with respect to. I would graph it symmetric with respect to the y-axis. Awesome. Okay, let's do one more. Let's say 47. In 47, we have f of x equals x times the square root of 1 minus x squared. We have the same question here. Is this function symmetric? I don't know. What do I need to determine? Yes, that's the starting point. I have to find f of negative x. Please dictate slowly, carefully, f of negative x. Remember what the pattern is telling us.
Negative x square root 1 minus.
Perfect. So negative x, with parentheses or not, is not going to make any difference here, because this is multiplied. The square root of 1 minus. Very good. Awesome. The negative x in front is negative x, but what about negative x squared? Very good. So this is negative x, the square root of 1 minus x squared. No one can further simplify this, so I have 3 questions that I need to answer, and only one of them has the answer yes. Does this equal the original function? If we say yes, it's even. Does this equal, what is the other option? The opposite, then it's odd. Or the first two are not working, then I'll say the function is not symmetric. A function doesn't have to be symmetric. It's nice if it is, because it will be easy to graph. So if I graph an even function, I graph this piece, and I don't have to worry about this. I just copy it. If I graph an odd function, I copy what I have here in the third quadrant, and I'm done. So it's nice if they're symmetric, but it doesn't happen all the time. So is this quantity the same with the original function? No. Is this quantity the same with the opposite? I don't know the opposite yet. Let me calculate the opposite. I multiply both sides by -1. If I multiply this, I get negative f of x. If I multiply this quantity, it's one product, I get this. So now I'm asking myself for the second question. Is this identical with this?
Yes.
So I will say this is the yes, and the other one goes away. This is how I determine whether a function or when a function is symmetric or not. Any questions here?
Could you just put this in a y equals in your calculator and put graph and then see if it goes on the origin or not?
You can't check, but if the problem is asking you to show it algebraically, you have to find f of negative f of x, and say yes or no.
Okay.
Yes, I agree. Okay, so let's choose a problem now. Any problem you want from 49, 50, 51, 52, and let's go through all those questions. So 49 through 52. 51 it is. So these are all on page 251. And we picked 51. So let's look at 51. And then from this section, we have to look at what is called a difference quotient. And then on Thursday, I'm trying to finish the review for 2, 3, and 4. And then hopefully next week we can have our test. We'll see. So we picked 51. And I'm just going to show you the graph on 51. It is something like this. And we have to answer a lot of questions here. So here's the graph, and we have questions from A through J.
So we have that there. Is that like the exact route?
Yeah, that's right.
Okay, first question. I'm also adding some questions for you here. Is this a function?
Yes.
By the vertical line test, this is a function. Very good. Can anyone give us the domain? So let me make sure that this is very clear to you. So domain.
Negative and then use it. Oh.
Three is here,
3,
and it continues
4.
4 with a bracket. Very good.
The range. Yeah, would that be the range? That's the range.
Range is up and down, domain's left and right.
My mind is already on range. I'm trying to negative infinity to 4. Thank you. Okay, very good. Yes, yes, of course. Of course. I'm 5 steps ahead without thinking. I can be 5 steps ahead, but I should be thinking. Thank you very much, indeed. I was looking at the range. Very good, thank you. Next question. The X-intercepts, call the zeros in this problem, of course. Zeros.
-3.
Yes, let's put them in ordered pair format. -3, 0, comma, and
3, 0.
very good, awesome. Next question, f of 0. When we're asked to find f of 0, what are we asked to determine?
0.
Y.
Very good. Awesome. Y-intercept. Yes, which is 0, 3. Perfect. Okay, next question. Intervals on which f is increasing. F is increasing on, let's see,
When it's negative infinity to 4.
not from which value of y to which value of y, but for, yes, between negative infinity and 1, the function is increasing. Between negative infinity and 1. So increasing on negative infinity to 1. Very good. The function is decreasing. That's the intervals on which f is decreasing.
Is that what a bracket is for?
We never put parentheses, or never put brackets for increasing, decreasing.
Okay.
Only parentheses.
So 1 to 3.
Indeed, 1 to 3. From x equals 1 till x equals 3, the function is decreasing. Perfect. Is this function ever constant?
No.
No. Values of x for which f of x is less than or equal to 0. This is very important. Let's discuss. Find x such that f of x is less than or equal to 0. Okay. Let's go back to the graph before we answer this. And let's talk about this. I see for x values between negative infinity and negative 3, the graph of the function is below the x-axis. What does that mean? That if I want to determine when x is negative 5, what type of number will I get? Negative number. Now let's see what happens here between these two. I see that the graph of the function is entirely above the x-axis, which means that if I pick any x value between negative 3 and 3 and want to determine the y value with a vertical line, at this point, I will read what type of number, what type of value? Positive. So I will say that when I analyze this graph, I will say that if I pick any x value between negative 3 and 3, the y values must be or 0, right? Because 0 here. But if I pick any number between negative infinity and negative 3, definitely the function values will be all negative because the graph of the function is under the x-axis. Agreed with that statement? So now I can answer. Find x such that f of x is less than or equal to 0. So between negative infinity and negative 3, the function will be less than or equal to 0. So negative infinity and negative 3. For x in the interval, any x value that you pick between negative infinity and negative 3, the function value will be 0 or negative. If I had only the strict inequality, I would have not included negative 3. But I include negative 3 because I also have the equal symbol. Yes, please.
Do we have to write it as the ordered term like that, or then set like that? Or
I cannot. Very good question. There are infinitely many values for x in which f of x is less than or equal to 0. It has to be an interval notation.
Okay.
Or you can say it in plain English, but it's not math. Negative 3 or less.
Okay, so we couldn't do x less than or equal to.
Oh, unless an inequality, you could. You could, but yes, this is good too. But we have to write the solution in interval notation. This is perfect. It's the correct answer. But we like to present the solution in interval notation. Let me see if it says. Where applicable, use interval notation. Okay, perfect. Any relative max and the numbers at which they occur. Okay, let's go back to the graph and analyze. I see it's increasing, and I see it's decreasing, and there is definitely something here that is called relative max or local max. Perfect. And what is the x value where that happens? How much is the y value? 4. So this is what I have to answer. Local or relative. Why is it? Because I can show the open interval. The function exists left and right, and all function values are smaller. Local or relative max at x equals 1. max value is
Four.
4. If you want, just to make sure that it's clear, you don't have to write this on paper. I'm just putting in parentheses. I read from 1, 4. That's the point I read from, 1, 4. 2 more questions here. The value of x for which f of x equals 4. The value of x for which f of x equals 4. F of x equals 4. Find x. What is given in the question? Very good. Y equals 4 is a horizontal line. At 4, here it is. This is y equals 4. Does it touch or hit or cross the function? Yes, at this point. And I have to read the corresponding x value, which is 1. So they're asking us again about that relative max. So I will say at x equals 1, f of x is 4. We read again from 1, 4. Final question. Is f of negative 1, is f of negative 1 positive or negative? Positive or negative? That's not what I meant to write, of course. This is what I meant to write. So, yes, because we already answered the question. So it will be negative if it's to the left of negative 3. However, I'm going to go and look. So here it is, x equals negative 1. It crosses the graph in this point. The graph at that point is above the x-axis. It must be positive, not negative. So f of negative 1 is positive. Any questions for me? Okay. I would like to talk about last thing of this section, the difference quotient and what it means. Now, how am I with time? I'm okay?
It's 2:40.
Okay. Oh,
It's 2:37.
okay. There's just 3 minutes. Okay. I'll stop. We're not going to be able I'm not going to be able to show you examples of this, but at least I show you what it is. And then I'll stop in 3 minutes, I promise. Okay, so let's say we have a function. And I'm going to create a point, P. Please tell me the x-coordinate. I'll give you the x-coordinate. You give me the y-coordinate. What is the y-coordinate? Thank you. I'm going to say this is point Q. And P and Q are very close to each other. They appear at a huge distance in my graph because I need to show you what I'm trying to explain. So, but this is just a little bit, tiny. And it's called, denoted by H. So this will be x plus H. So can anyone give us the y-coordinate for Q? Thank you very much. And this is what we just did a few minutes ago. And the next step, I'm going to draw a line segment through these 2 points. And I would like you to give me the definition of the slope of PQ. Slope of the line, PQ. And just tell me what to write. Correct. But now this time I would like you to use what we have. But you're right. Let me write it. Maybe that's even better. y2 minus y1 over x2 minus x1. But now I want these to be in the concept of our problem. Perfect. That's the answer. But I would like to fill in.
F of x plus minus f of x.
Awesome.
Right.
You're right, but you're 10 steps ahead of me.
X plus h minus x.
Very good. The only thing I can do here is what? I cannot touch this, untouchable. I cannot touch this, untouchable. But what can I do here? Very good. So this is f of x plus h minus f of x divided by h. This is the dq, or the difference quotient. I'll explain what it means next time, and I will also we will also have problems to work with.